Okay, we're recording now. So after our little bit of a discussion, I will recap. CyberKey sent us the correct codes after sending us the wrong codes. So I have the documents out there and announcements with the correct digital forensics essentials codes. So go ahead and make sure you can get those. If you can't, screenshot the error message and send it to me in Discord. I cannot see any of the students or any of the classes right now. I have contacted our rep. So right now, because I don't have a whole lot of faith in the new system because of this, please screen cap, please snip your progress, and you can either email if you want to email, but I am perfectly fine with you sending that to me on Discord, and I will keep records of that so that I will have that as a backup in case I'm never able to see it the right way, which I really hope is not a thing, but at this point I don't have a whole lot of faith in what I will or won't be able to see. So that's what's going on with that. All right, so we have the stuff pushed out. Go ahead and as you get in, work on your labs. If you have any problems with the system, remember what we did with the CEH when it gave us all sorts of fun. Just make sure you screen cap the print screen the error messages so I have proof so I can bombard them with that. And if you put any tickets in, give me the ticket numbers, okay? I'm sorry, guys. I know this is incredibly frustrating, and I am incredibly frustrated for you guys as well. All right, so all that fun being said for the labs, let's go ahead and start in on the lecture portion of today, and then I will talk to you more about homework later on. Okay. So today we are doing Module 9, and we are talking about investigating web attacks. Okay. So what's going on in this module? Looks like we're going to do web application forensics, IIS logs or Internet Information Services, Apache Web server logs, overview of web attacks on Windows-based servers, and understanding how to detect and investigate various attacks on web applications. I personally find this really interesting because I've worked with a lot of web servers, and a lot of misuse and attacks are done against web apps and web servers. So here's our module flow. The first part is the web application forensics. So what is web application forensics? It involves tracing back a security attack that occurs on any web application to identify its origin and how it was penetrated. Includes the collection and analysis of log and configuration files associated with the web server, application server, database server, any system events, or anything else to determine the cause, nature, and perpetrator of the web exploit. All right. Challenges for web application forensics. Due to the distributed nature of web applications, traces of activities are recorded across numerous hardware and software components. Very limited or no downtime is allowed for investigation, so it makes it very difficult for you to get all of your logs and evidence. Web application forensics requires the analysis and correlation of huge volumes of logs. It also requires complete knowledge of different web servers, application servers, databases, and their underlying applications. Tracing back is difficult in case of reverse proxies and anonymizers. Now, a lot of the times, you never can do a full trace back because of this, but you can at least figure out how they got in and shut off the ability for them to try that again. And if they try it again, it's kind of like you get a step closer each time someone tries to do that. So what are some indicators of a web attack? Customers being unable to access services, web page defacements, that's a huge indicator. Suspicious activities in your user accounts, unusually slow network performance, leakage of sensitive data, frequent rebooting of the server. You should not have this on a big server. A lot of times server downs and server rebooting, they're all set at very specific times because you don't want those servers to go down when customers are using them. So if it's randomly rebooting in the day, that is a huge indicator something's wrong. And then of course, URLs redirecting to incorrect sites, also a good indicator. Yeah, can confirm, exactly. Okay, here's some nice big pile of web application threats. So we've talked a lot about this because it's such a big attack surface for cybersecurity. So cookie poisoning, SQL injection flaws, cross-site request forgery, directory traversal, unvalidated input, cross-site scripting, sensitive data exposure, parameter or form tampering, DOS, broken access controls, security misconfiguration, information leakage, improper error handling. That one happens more often than people like to admit. Buffer overflow, that one's gotten less and less. That one is usually because of server or of setting problems or programming inconsistencies. Insufficient logging and monitoring, broken authentication, and log tampering. All right, so we have different types of methodologies. So what is an example of, what are examples and ways that we do web attack investigation methodologies? So we conduct individual interviews to obtain information, locate the servers or other devices that are involved in the security attack, take them offline and perform seizure in a forensically sound manner. That can be difficult because companies don't want you to take them completely offline to do a full forensically sound seizure, because that means that their customers are not going to be able to access things. Well, if you don't do that, just people accessing the site or whatever it is can change any sort of data right there. So it can mess up the whole investigation. Yeah, any sort of thing if it goes down, even if it's down for maintenance, people get angry fast. But it's kind of that catch-22. If you don't take it down, at least for a certain amount of time to get a nice forensic image or get the data off of it, you can't get forensically sound information. Because if it's live, we've talked about if it's live and it's changeable and, then you get changed data that you can't really say, okay, this is something that we can use in a court of law if you have to use it, because, you can't. So next, we have our follow process for forensic image acquisition and duplication, which you can't do if you don't take it down. Collect your logs from the web servers, applications, database, firewalls, local system events. You get them from everywhere. And a big problem with this is people do not collect all of the logs, or they collect part of the logs. The best thing to do is to get like a checklist and make sure you run through the checklist of everywhere that you might need to check, because you might have a critical piece of evidence in one of these logs that you just completely missed because you never went out and checked for it. And logs are also changed if you don't have systems down to get them. Use encryption and checksums to verify and protect the integrity of your log files. Analyze the working copies of collected logs and look for suspicious entries and correlate the data. Hey, stop. To build a chain of events unfolding the whole attack scenario. Trace the attack IP to identify the perpetrator of the attack, or try to. If they bounce it around all over the world, sometimes you don't get all the way back to it. But you can try to get as close as possible. And then document every single step of the investigation. Next, IIS and Apache web server logs. So IIS web server architecture, I got very familiar with this because this is where I first started, and then we started shifting over to Apache later. So you can see on the top here, we have our client. Then we have stack, or HTTP protocol. So IIS is Internet Information Service for Windows Server, and it's flexible, secure, and easy to manage web server for hosting pretty much anything. And then you can see down here, you have your SVC host, EXE, and you have your application pool, and then you have your external apps. And this is how everything kind of links together. You have your web server code, or web server core, your native modules, and then you can see your little app domain, managed modules, and form authentication in there as well. So this is just a quick overview on that type of architecture. Now, there are a ton of different logs that you can find on IIS. It logs all server visits in the log files. The logs provide useful information regarding activity of various web applications, such as IP address, username, date, and time, request types, and target of operation. The IIS server generates ASCII text-based log files. And on Windows Server OSs, the log files are stored by default. And you can see here that inetpub, that is your base for where you see pretty much all of your published website stuff. And then everything comes out on the different files after that. And you can see over here is an example of what one of those log files looks like. So how do you analyze this mess of text? Well, this is a very nice little slide telling you exactly how these break out. So the top part is your date and time. Number 2 is your server IP. 3, that's what type of command they had there. This was a get command that they were using. The user issued a get or a download command. 4 is telling you what they were after. That looks like they were attempting to get a picture. Probably it was something related to the website that was pulled down. There's 5 is your URI query did not occur. There's the port. There's the username, if there was one. This one's anonymous. There's the client IP address. There's the type of browser that they're using. Then there's the web page that provided the link to the website. And then there is the request was fulfilled without error. That's that code that you see. And then the action was completed within how much time? 365 milliseconds. So if you're trying to read this pile and you don't know what everything means, the first few times it's best to have a little thing, cheat sheet kind of like this up. The more you look at it, the faster you start picking things like IP addresses and things like that out. Okay, Apache web server architecture. So as you can see, this one is a bit different. You have your Apache core, and around that you have your HTTP main, HTTP protocol, request, your core, and then down here, the core reaches out for utilities and your resource pools or allocation, which is where all those are. And then on this, there's the Apache module and your handlers. This is, there is IIS being used and there is Apache being used. They're both still in service. IIS came first and Apache is something that came after that, but that doesn't mean they aren't both being used at the same time. So how do the logs differ? Apache has the HTTP server logs, which is a web server, and this supports your OS. It has all sorts of different OSs you can do, like Unix, GNU, FreeBSD, Linux, Solaris, all sorts of those. The log types, it has two types, access and error logs. And then Apache log information, they provide information about web application activities, such as, nice little list here, IP address of your client, ident of the client machine, user ID of the client time, request line from the client, status code, and size of the objects returned to the client. So, what does that look like? It contains requests processed by the Apache server, and the default locations of the access logs are, and you can see down here, some examples, and then you see over here on the right, exactly what that looks like. This is the access log version of that. So, how do we look at that? You notice there's a significantly smaller amount of stuff here. They tried to simplify these a little bit more when they went from IIS to Apache. So one, that's our IP address for your remote host. Two, request information. It says that's not available, so I don't really know. User ID, well, this one's listed as JSON. 4 is the time and date when the server received your request. And then this one, the request line by the client, the request method and protocol used. So this one's a GET, and then it has the list of what it's after. There's an HTTP code status, so that's 500. Now, if you don't know HTTP status codes off the top of the head, and I can't remember a lot of them, but you know those jokes about 404 file not found. That's the type of thing that they're talking about. There are, if you can go out and get type HTTP status code cheat sheets, and it'll tell you all of those. And this bottom one here is the size of the object returned in bytes to the client. So here's the longer example of your access log. So the reason this one's longer is because it's a little bit longer what they're after. I think 500 is server error, Gwen. I just can't remember exactly if that's generic server error or if it was something specific. Okay, so we have 1, 2, and 3 on this one. The first one, the format resembles a common log format, which you can see here. And the second one refers to HTTP request header, which presents the previous web page address visited by the client that redirected them to the current web page. So that's why these are longer. They have more information in them. And then the other one is the user agent HTTP request header, which provides the details of your platform system and browser that the client is using. So you can see here, this is Mozilla. It's on an Ubuntu Linux system, and you can see this here, all this stuff in there. Error logs. Personally, access logs have a lot of stuff in them, but whenever I've done investigations, I've actually found more information on error logs than anything else. So on the Apache server error logs, the server saves diagnostic information and error messages that it encounters while processing requests in those error logs. And then the default locations are listed right here. And you can see over here some examples of what those look like. Hopefully we have an example of, yes, okay, we do. Here is how you analyze an Apache error log. So the first part is our date and time of the log. 2 is our severity of the error. 3 is the process ID and thread ID. And pretty much all of this stuff you can look up online, except for your own IP addresses. You should have those available to yourself. I had an easier time with IIS than I did Apache. I will honestly tell you that. But once you get into Apache, I've heard that you have a harder plateau learning it, but once you get into it, you can easily. What I'm trying to say is it's not a demon. There is a harder initial plateau to learn, but you do, I think, get a lot more information out of some of the things because they tried to simplify some of the areas of storage on it. Okay, and 5, here's your what it's trying to say, file not found on this one. And then what was it after is there. And so that was an object. It's looking for a generic picture in an images folder. So it couldn't find it, obviously, which is why it had an error message. Okay, are there any questions about those IIS and Apache before I get you over onto the next portion? No, it's Monday. Stop asking me questions. Okay. Okay, we're doing brain hurting. Okay, good to know. Investigating web attacks on Windows servers. So your event viewer is one of your first places to go. And as you can see right here, that's one of the places that you can run, how you can run your event viewer. Check if the following suspicious events have occurred. Event log service has ended. Windows file protection is inactive on the system, or Telnet service is running. You should never be using Telnet because it's all in plain text. No sane organization or service network people, or you should just not be using Telnet. If it is running on your system, then there is a problem. Find out whether the system has any failed login attempts or locked out accounts. And also the amount of failed login attempts, the amount of times the accounts have been locked out. Because I will say, yeah, you would think so, but you would not believe how many just times the servers are get hammered. But because a lot of times you have those script kiddies that get bored and they're like, I'm gonna try this, and then you have like 30 million attacks of random failed login attempts, and that'll tell you whether or not you have an issue. Yes, exactly. Let's go try to DDoS somebody. Yep. Okay. Here are some other things. File shares. Try to figure out what they're there. What are they there for? What's their purpose? Verify users that are using open sessions. If there are open sessions, check if the sessions have been opened with other systems. Analyze the net BIOS over TCP/IP activity. That's that. Remember that NBT stat-s. We've talked about that a couple times. And then find if your TCP and UDP ports have any sort of weird listening going on. And you can see over here, there's some examples. And you see on there, we have our addresses, and you can see what states they're in. We've got listening, we've got established on some of these. And, you might want to You might want to see what they go to, because a lot of times in an organization, well, actually, I say a lot of times, a good organization keeps a list of all of your your static IP addresses that are required to be used and left open for different services. And if there's something in there that you're like, okay, this does not look right, you should be able to shut it off and not cause any sort of issues with any sort of internal networking. And if you do, that means they have not updated that little sheet, and that's not your problem. That's whoever it was that was supposed to update its issue, in which case snipping and print screen are your friend, and you can say, maybe if you had updated this, I wouldn't have done that. So, and I totally don't say that from experience. Find scheduled and unscheduled tasks on your host, your local host. There's an example of how to do that. Check for creation of new accounts in the administrator group. You definitely want to keep an eye on that. Check whether any unexpected processes are running in your task manager. Check for unusual network services. And check file space usage to find any sudden decrease in free space. You want to make sure no one's suddenly dumping things onto your server that isn't supposed to be there. Okay, next we have to detect and investigate various attacks on web apps. So, remember our fun friend cross-site scripting? So common cross-site scripting attacks use HTML tags like script, image, input, and body. Attackers use various obfuscation techniques to avoid detection by firewalls, IDS, IPA systems. Like they can do hex encoding, inline commenting, char encoding, toggle cases. They can replace keywords, or they can do things like white space manipulation. So, for example, all the scripts below technically have the same meaning. And you can see this is just an example of them using things. You see, so that one on the top is an example of what it is. This next one down, that's how they use toggle case. The one down from there, that's what it would look like with hex encoding and then double encoding. And I like this. This is a really good example of things to look for because a lot of times they're like, you can do this, but they don't show you exactly what it means. So this is a great example. Investigators can use regex to search and find HTML tags, other cross-site scripting signature words, and their hex equivalents in web server logs, IDS logs, seam tool alerts, etc., to check for attacks. A lot of times, if you have someone that's doing this, or you can, do you remember how we talked about putting in input validation? If you're, a lot of this stuff, they shouldn't be able to put in period, like you won't allow them to input certain characters like the percent signs and things like that to stop them from doing any of this sort of thing. But you can also put in, you can use PowerShell and some other things like that in order to create scripts to go out and search through this stuff just in case. Because there's always someone that's clever that figures out a way around what you're doing. Because there are people that have nothing but time, that's all they do. And while you have to, secure all of these systems, you might have one person that spends hours and hours and hours doing nothing but trying to break that system. And so, when they have that kind of time and tenacity, sometimes they'll find a way around. Using regex to search for cross-site scripting strings. So the regular expression below checks for attacks that may contain HTML opening and closing tags. That's an example right there, with any text inside, along with their hex and double encoding equivalents. So you can see we have some very good examples. The first one checks for the opening angle bracket or its hex or double encoded hex equivalent. The next one checks for the / and closing tag or hex or double encoded hex equivalent. And then checks for upper and lowercase alphanumeric strings inside the tag or their hex representation. And then we have one that checks for the closing angle bracket or its hex or double encoded hex equivalent. So it is really nice. This is a very good one that I would personally steal if I were you, if you're going to be doing any of this, because a lot of times they don't have these representations in just one cheat sheet. You have to have multiples. So this is a good slide for your resources. So back to Apache. And if you're looking through Apache logs for this, this is what we get to do. The highlighted log entry in the Apache access log file shows a GET request followed by hex encoded values in the query string. Decode the query string to determine whether it contains malicious HTML tags. And you can see here it has examples. That's why I like these slides they have in here. It actually has, hey, this is the hex encoded value, and this is what the decoded character would look like. So that's kind of a nice thing that shows you exactly what you're looking at. Decoding the values reveals that the log is associated with a cross-site scripting attack. The detailed analysis of the log has provided the following findings. The attack originated from, and you see now under that one there, that IP address, and there's the date in June, which is just rude because June is my birth month, so I'm like, rude. And then we have malicious cross-site scripting, you can see here, which converts to, and it shows here, and then it shows you the page that it was injected to by the attacker. It's kind of backwards showing it here, but that's just because of how it encodes. And then we have our HTTP 200 status code, which can be observed, implying the web application server actually processed that request. Aha! Another June. I got all my June people. Boo, summer babies. Yeah, I am June 8th. That is when mine is. I don't know what it is with my family. We have a whole bunch of Junes. My adopted niece is in June. And then I have 3 of my favorite martial arts students that I adopted. I have a set of twins. They're I think the 14th, and their brother is a couple of days after that. So, but I like all of them. So, oh, that's funny. You share a birthday with your younger brother. Yeah, I call them my twins, but that's just because I adopted the family. I taught martial arts to them for years and just kind of adopted the whole family because they're just absolute sweethearts. And so kept in touch with them over the years. And I enjoyed watching the twins because they would bicker with each other. They were 2 girls and they had an older brother. And they would bicker with each other, but the minute you picked on one of those twins, both twins would turn on you. And it was one of the funniest things I'd ever seen. So it gave me a lot of insight into sibling rivalry, but also they were very close, and you did not mess with one of those siblings. Anyway, but both of my parents were born my dad was in January, my mom's February. So you never know. Okay. And I forgot to turn off my phone. Sorry about that. So anyway, that is our nice pile of examples for cross-site scripting with Apache logs. Next, we're going to talk about snort alert logs. I always thought that was hilarious, but you know how we talk about sniffing? Snort is what you use for that. So snort alert log for cross-site scripting is what we're doing here. And this snort IDS has generate an alert for a cross-site attack attempt with the following details. And you can see we have a nice little red around there. So our source IP is that 192, which you can see, that's the nice thing about snort is it literally blocks out the sections for you. And then we have our destination IP, and then we have our source port and our destination port. So it says, hey, we got a problem here. And here is an example of what it would look like. And these are scene logs for a cross-site scripting attack. This is Splunk. This is an alert. It's collected from a snort RDS. This one, as you can see here, has the date and time, and you can see how it's blocking everything out here. The attacker's address, and then it says what port they're using, the target server, and the port they're attempting to go after there. As you can see, a lot of times they go after those HTTP ports, anything that's not, yeah, I always thought it was funny. I'm not sure who came up with Splunk or Snort, but I think a lot of times they just try to come up with the funniest sounding words. I think it's just part of IT. They try to come up with something silly so that people will remember the tool names. So anyway, that's what that looks like on there. I like this one because of how easily readable it is. And you can see it literally pops out classification, cross-site scripting attack attempt. So that's always a nice one. I'm not going to take money on that, but I could believe it. Okay, investigating SQL injection attacks. So looking for SQL injection attack incidents in the following. This one I've had a lot of experience with. The database manager and myself would go through and look at all sorts of things like this. We looked at log files, web server log files, and things like that. These are some examples on here of what SQL injection attack signatures in web server files may look like. And they did a lot of times they really did look almost exactly like this. Anytime you see where they're trying to throw in, a lot of times I would also see where you could actually see chunks of that SQL code, where you'd see this in here, and then you'd see, what do you see? Remember that, I'm spacing on SQL for until I've been doing a lot of stuff this last few times, but they'd have these single quotes, and they'd say things like table, get table, blah blah, some things like that. Like you remember from our MySQL, get username, get database, get, you'd see things like that, and you'd go, oh, someone's trying to throw SQL in there, trying to see if maybe we don't have that function locked down. Here's some examples for investigating SQL injection attacks using regex. You can do a regex search in the log files to look for the presence of SQL-specific meta characters. Like I said, the single quotes, double dash, equal signs, semicolons, and then the other thing that they try to hide is they try to use those hex equivalents again. And it's nice having an idea of what those look like in order to attempt to find those. So here are some regular expressions for detecting SQL meta characters. You can see here, and these are modified regular expressions. And then you have regular expressions for detecting typical SQL injection attacks. And if you see anything like this, especially with the brackets, the asterisk, anything like that, there's a good chance that that's in there. Regular expressions for detecting SQL injection with union. Regular expression for detecting SQL injection attack using MS SQL Server. And you can see that right here. This is another really good one to swipe the slide for your resources. All right, IIS logs for SQL injection attacks. The GET request, a lot of times for SQL, you're gonna see the GET request in these. So just keep that in mind. So the GET request in the highlighted IIS log entry contains some SQL meta characters. Some are encoded. And then with the characters decoded, you see the query right here translates to ID, and you can see right here, which indicates an SQL injection attack. So they've got, they're looking for an ID that of some sort. They're attempting, anytime you see those single quotes, the equals, the double dashes, you know, I mean, you got a whole bunch right there that indicates it's an SQL attempt. Detail analysis of the IIS log provided following information. The attack was performed on a Linux machine. There's the IP, there's the date. The attacker logged on to the website that's listed here. There's the hosted server IP, the username Bob, and inserted that malicious SQL query into the order details page. Now, a lot of times they throw those into ordering websites because, as we talked about before, they do not sanitize their code inputs, and they can throw stuff like that in and get like your entire customer database if they're really good and things have not been sanitized, or your entire inventory if you're really if they're really bad checking that's been done. So on this one, the status code means the web application server actually processed that request, allowing them to go right past authentication. And they went into the order related data on the database. So that is very bad that it even got in, let alone passing that through right past your authentication. Snort alert logs for an SQL injection attack. So in this screenshot, you can see the Snort has generated an alert for an attempted SQL injection attack that has the following details. So we have our attacker IP address, server address, you can see the source port, and again, thereafter that destination port 80. So here's a scene log. It's, as you can see, significantly longer for an SQL injection attack. But that's just because this person is probably trying to shove a whole bunch of stuff in here instead of trying one or two things at a time. Usually with an SQL attack, they may try one or two things just to see if the characters will go through first, and then they will start hammering things from an actual query through. So on this one, a Splunk triggered alert sourced from an IIS log shows an SQL injection attack attempt as a result of a search query with the following details. There's your attack time from that IP address. They used what's called Firebox browser on a Linux machine, and they submitted that query that's listed to perform the attack. All right, so what did we learn? This module discussed web application forensic fundamentals, discussed internet or IIS logs and Apache web server logs, discussed in detail investigating web attacks and Windows-based web servers. This module also discussed identifying indicators of compromise or IOCs from network logs. And finally, they talked about detailed discussion on detecting and investigating various attacks on your web applications. Okay, so Wednesday, we will be talking about dark web forensics, which I'm actually looking forward to as well. So that's what we went through today. Are there any questions before I stop the lecture portion and talk about homework? Everyone's brain hurts. All right, I'm going to go ahead and stop right here.